morning students. Today we will start decoupled load flow. So I will assume that you are aware of Gauss-Seidel method of load flow and Newton-Raphson method of load flow. So from Newton-Raphson method of load flow, we have observed that del P and del Q may be written as, this column vector may be written as Jacobian matrix whose elements are J11, J12, J21 and J22. And the corrections or variables are del delta and del V. Vectors, all are vectors. This matrix, Jacobian matrix, is having four sub-matrices J11, J12, J21 and J22. So what is del P? What is del P? Okay, before that recall SI star injected at ith bus is nothing but Pi minus JQI is nothing but Vi star II phasor. That can further be written as Vi star summation k equal to 1 to n, wherein is total number of buses in the system Yik. So if we are going to represent these phasors in polar form, that is, this Vi phasor is nothing but Vi magnitude angle delta I, or Vk delta k, and Yik magnitude Yik angle theta. So the same can be written as, this will be equal to Vi conjugate is there, so this will be minus delta I summation k equal to 1 to n. Yik may be written as this magnitude Yik theta Ik times Vk. So Vk is Vk angle delta k. So taking all magnitudes together, we may write Vi, these all magnitudes, Vi k equal to 1 to n, this magnitude Yik, Vk, Vk, all magnitudes together and angles together. So angles are theta Ik, delta k, delta I. Theta Ik plus delta k minus delta I. So from here, Pi and Qi may be written as, real part of this will be Vi 1 to n Yik Vk cosine of this angle theta Ik plus delta k minus delta I. Similarly, mark this equation, say equation A, very important equation, and Qi, this minus sign is there, so take negative, same magnitude Vi, k equal to 1 to n, Yik, Vk, sine of same angle, theta Ik plus delta k minus delta I. So what is this delta P? Delta P is nothing but difference of a specified and this is variable, right?
Yes.
Variables are Pi, Qi, Vi and delta I. For any bus, each bus of the power system is characterized with four variables. So this is not fixed variable. So ideally it must be equal to the specified value, either PQ or PV. Both buses are having P as specified, is not it, whether PQ or PV. So this should be ideally equal to a specified. So, but nothing is ideal. That's why we have introduced this variable del P. So we are going to solve this so that once solution is reached, then the value of this will be nearly equal to 0, del P or del Q, is not it? So difference of del P is nothing but Pi is specified, this is fixed constant, right? Minus this Pi. This Pi is function of delta and V. This is not variable. Yik is not variable. That is fixed element of bus admittance matrix. So Pi is function of basically delta and V. Is not it? This is constant. This is function of delta and V. It means del P is function of delta and V. So in a steady state, whatever the solutions we have obtained for delta and V, delta means delta is variable for which bus? PQ bus. So for all PQ buses, all deltas. Suppose PQ buses we have assumed from bus number 2 to M. So delta 2, delta 3, delta up to delta M. Is not it? So it depends upon number of PQ buses. What about V? V is variable for?
PQ bus.
And what about PV? Delta is variable or? So delta is variable for both. We have discussed for PQ. So this is variable for PV also. And what about V?
PQ.
This is variable for PQ only. So depending upon various combinations of buses, the dimension of these variables will be variable. So for a particular set of PQ and PV buses in a system, the set of variables will be there, and these are represented by del delta and del V. Del delta is basically correction in delta required to be added in the initial guess so that we will get the solution. Whatever value of x you have assumed, if delta x you are assuming correction, so x plus delta x will be solution. But you don't know delta x, that is your task to evaluate, right? So you know delta P and similarly delta Q. What is delta Q? Similarly delta Q is Qi specified minus this variable. So we may say that as this is function of delta V, so delta P is also function of delta V. Is not it? Constant function minus some function is function. Is not it? So this is function of delta and V. This is also function of delta V. So this is also function of delta and V. And these are the corresponding corrections in the variables which you are required to evaluate using Newton-Raphson method of load flow. So whatever initial set of variables you are assuming, at the same assumed value of variables you are evaluating this, then you are evaluating this, you are getting this, you are updating the variables and so on. You know the steps of Newton-Raphson method of load flow. Just focus here. This says that this delta P depends on these two variables, is not it? How? J11 del delta, J12 del V. What is J11? This is also matrix. So suppose this is 1 and 2 left hand side, this is 1 and 2 right hand side. So if you want to write J11, so J11 means first one is 1, so P, second one is 1, so first one delta. So this will be nothing but this matrix, del P upon del delta. We will again see how to evaluate this, right? So similarly, what about J12? First one from the left, second one from the right. So write this matrix, del P upon del V. Clear? Similarly, J21, second one from the left, that is del Q. First one from the right, that is del delta. And what about J22? J22 is second from left, second from right, del Q upon del V. This we have already discussed during Newton-Raphson method of load flow. Just recall these relationships. Now, with certain assumptions, practically feasible assumptions, we will see that it has been observed that this del P mainly depends on del delta. Or in other words, P is more dependent on delta than V. What is delta? phase angles of bus voltages. What is the magnitude of bus voltages? You know that, right? So this P mainly depends on delta, or in other words, P is more dependent on, we will see it, we will prove it, than V. And what about Q? Q is more dependent on V than delta. What is V? Bus voltages of several buses in the system. What is delta? Phase angle of bus voltages. Clear to all of you? So if we are saying that this is mainly depending on delta, it means this is nothing but this into this plus this into this. It means we are saying that this should be 0, nearly equal to 0. Is not it? And we are saying that Q is mainly depending on V. So in other words, we are saying that this times this, that is, this should be 0. So these are the major changes in Newton-Raphson method of load flow, and we are decoupling here. And that's why the name decoupled load flow is given. What is the name of this load flow? Decoupled load flow. Decoupled load flow. So now, if we are assuming these two submatrices as 0, so this will become decoupled load flow. We have decoupled here, and then we may write del P is nothing but, del P will be this times del delta. Is not it? We will write del P will be, J11 is nothing but del P upon del delta. What is this? Del delta. And what about del Q? Del Q will be, this is 0 now, so that is J22 del V, and J22 is del Q upon del V times del V. So these two equations so now we will see how J11 is non-zero, J12 is 0, and here J21 is 0, nearly equal to 0, and J22 is non-zero. We have to see. Any question till now? No question. Okay. So transmission lines are highly inductive in nature. Do you know? Highly inductive means, okay, this is YIK, element of bus admittance matrix corresponding to ith row and kth column. It means if ith bus is connected with kth bus, then we will get some non-zero value, and that transmission line is highly inductive in nature. So if in polar form, from polar form to rectangular, we may write YIK cos theta ik plus j times, right here, plus j times YIK sin theta ik, is not it? So that is nothing but equal to, this YIK is equal to GIK plus j times BIK, real part of this and imaginary part of this. So what is this? Conductance. What is this? Susceptance. So as the nature of transmission line is highly inductive in nature, it means which one is dominating? So this is very, very lesser than, we can ignore this. So that's why we may write GIK is very, very less than BIK. Okay, this is phase angle. So during stability analysis in coming lectures, we will see in detail. So we can see that difference of two deltas, suppose delta I and delta J are not very much high, very less. So we may assume that these differences are nearly equal to 0. Two assumptions here. One assumption is GIK is very less than BIK. You know what is GIK, what is BIK. Why? You know, you can justify it. Is not it? Second assumption is that difference between delta I and delta J, where delta is phase angle of bus voltage at ith bus, this is at jth bus. So these two differences are within 10 degree practically, not more than that, within 10 degree, less than equal to that, right? Due to some other reasons, we will see in detail in stability analysis, unit 4. So these are two assumptions, and with these two assumptions we will see that these two submatrices J12 and J21 are 0 here, and remaining two matrices, submatrices J11, J22 will be non-zero. We have to prove it. Any doubt till now? So what we have assumed? Assumption number 1, this. Assumption number 2, this. Clear? So first write for 0 elements. Start for 0. And okay, first write, show that this is not 0 with these two assumptions, and this becomes 0 with these two assumptions, so on for this. So start with J11. So J11 is del P upon del delta. So depending upon number of PQ and PV buses, the dimension may vary. Is not it? Suppose we have 10 PQ bus and 10 PV bus, 5 PV bus. So how many P will be there? 10 P for PQ and 5 P for PV. So total 15. Is not it? And what about delta? This will also be 15 because delta is variable for both PQ and PV. So dimension of this will be 15 by 15. So depending upon the various combinations of this, right, we may evaluate the various dimension of these submatrices, right? So just write del Pi upon del delta J. So I and J may be equal or may not be equal. So take first case not equal, and then take another case equal. Not equal means, you know, if this is having dimension 15 by 15 for this assumption that we are having 10 PQ buses and 5 PV buses. So this will be 15 by 15. So how to write the first row? So first row will be del Pi upon del delta 1.
Yes, sir.
First row, so I will be 1. Del P1 upon del delta 1. Del P1 upon del delta 2 up to del P1 upon del delta 15. So dimension is 15. So write second row. Right, last row will be del P 15 upon del delta 1, del P 15 upon del delta 2, and so on. You may write that, right? So write directly del Pi upon del delta J, because in the elements of this matrix, somewhere I and J both are equal, somewhere not equal. Only these two cases may be there, right? Is not it? So take I and J, where I is ranging from 1 to, for this case, 15. Is not it? And J ranging from 1 to 15. So somewhere you will get P3 upon J3, delta 3, right? Is not it? So somewhere both are equal, somewhere not equal. Suppose you are getting del P7 upon del delta 3, not equal. So both the cases we will see individually. So first take this case, del Pi upon del delta J. Pi is this. So partial derivative, our variable is delta J. So search for delta J here. So this is ranging from 1 to n. So when k is 1, this is why I1 independent of delta J, B1 independent of delta J, delta 1, delta I, all independent of delta J. So 0, k is equal to 2, all independent of delta J. So 0, take k is equal to J. So there you will get delta J. Only that term is depending on delta J. Clear? So first derivative of this will be, this is cosine.
Sine. Minus sine.
Okay, tell me what it will be. We are writing for k is equal to j. For other values of k, the whole expression is independent of delta j. So partial derivative will be 0. So directly we are writing kth term, sorry, jth term when k is equal to j. So at that time this k is j. So this is delta j. So we are going to differentiate this whole expression with respect to delta j. So tell me, this is cosine.
Minus.
So minus sine of this, is not it? And derivative of this will be 1. So directly write minus whole thing vi, is not it?
Yij.
K equal to 1 to n yik. Okay. We have taken separately, right? So no need to write all terms. Directly 0, 0, 0 and k term, right? Y ij
Bj.
sine of theta ij
Plus delta.
plus delta j minus delta I. Is not it?
Yes, sir.
So simplified. So for all elements of this matrix, when I is not equal to j, directly you can substitute the values here and you can calculate the elements. Is not it?
Yes.
So simple. No need to evaluate all and like that. It is simplified version, right? Okay. So this is yij. And this is, take separately, this is theta ij. This is not variable. This is fixed. This is variable. So we are having sine of some parameter, fixed value plus some variables. So this can further be written as minus vi. Take all voltages together. Vj, yij, and sine a plus b. So that will be sine a into cos b. Sine a into cos b. What is sine a into cos b? Sine a plus b. Sine a into cos b plus cos a into sine b. Okay. Plus cos, what is it? Theta ij